So in this video, I wanted to go over the solutions to the practice calorimetry problems. One thing that you'll notice about these problems is that they're all based on the same assumption, but there can be slight differences in how you do these based on what the question asks. Right? So the assumption that all these are based on is, and that assumption is going to be that the heat that is lost or gained by the water is going to equal the heat lost or gained by the object, right? And so notice this could be either of these words, but whatever the word is that you have here, it's going to be the opposite over here. So if it's heat lost by the water, that's going to equal the heat gained by the object. Or if it's the heat gained by the water, it would be the heat lost by the object. All right, so it's always going to be opposite on the other side. But either way, what this allows you to say is that the mCp delta T, the mass times the specific heat times the change in temperature of the water, is going to equal the mass times the specific heat times the temperature change of whatever the object is that you're putting in the water. All right, so let's take a look at this problem here and see what we can identify. Okay. So the first thing is that we have 340.0 grams of water. So we know the mass of the water, and it says what the, so if it's water and it's liquid water, we know what the specific heat is. That's going to be 4.18 joules per gram per degree Celsius. And the temperature change, all right, we have a final temperature right here, and we have a starting temperature of the water right here. So we can figure out the delta T of the water. All right. We can tell from the problem here, it says find the mass of the copper. So we know that's the thing that we don't know. So that's question mark. We know that it's copper, so we can look up its specific heat from the reference guide. So we know that. And the change in temperature. All right. So we know it starts off at 500 degrees. And the final temperature of the water is 42 degrees. All right, and so remember, the hot object that you put into the water, its final temperature will be the exact same temperature as the final temperature of the water, because that's the reason it's the final temperature. The temperature of the water changes as long as the hot object is giving heat to it, and once it stops giving its heat to the water, once their temperatures are exactly the same. Remember, that's why something gives heat to something else, because of a difference in temperature. All right. So let's rearrange this equation for the thing that we don't know, which is going to be the mass of the copper. All right. So we can do that, and I'm going to put the mass of the copper on this side, and we can say that it's going to equal the mCp delta T of the water over top of the Cp delta T of the copper. All right, so let's fill things in. We know that the mass of the water is 340.0 grams. Specific heat is 4.18 joules per gram per degree Celsius. We know that the change in temperature is going to be 42.0 minus 10.0, so that's going to be 32.0 degrees Celsius, all over top of the specific heat of copper. Putting that over top of the specific heat of copper, which you can get from the reference guide, and the change in temperature of the copper. All right, and so this value comes from the start temperature of copper minus the final temperature of the copper. Remember, the final temperature of the copper is the exact same thing as the final temperature of the water. All right, so taking these numbers right here, plugging them into your calculator, and taking a note of significant figures, this answer should have 3 significant figures, and that would end up being, when you round, it's going to be 258 grams. All right, for the next problem. Okay, we're going to start off with the same basic assumption, which is that the mass times specific heat times the temperature change of the water is equal to the mass times the specific heat times the temperature change of the metal. All right, and so let's take a look at the problem and see what we know and what we don't know. All right, so mass of the water. All right, that's given in the very first part right here. So we know that. All right, so we know the specific heat of the water and the temperature change of the water. All right, so we know a starting temperature of the water right here, and we know that this is eventually going to be the temperature that it warms up to. So we can take the difference to get the temperature change of the water. All right, the mass of the other object, it is given right here. We don't know the metal, so therefore we don't know what the specific heat is. Okay, so that is the question mark, and the change in temperature is going to be the difference in temperature from the starting point of the metal, which is right here, to the ending point, which is going to be the end point of the water. All right, so what we can do is we can rearrange our equation to get specific heat of the metal by itself, and that's going to be equal to mCp delta T of your water. All three of those are going to be for the water, over top of m delta T for the metal. All right, so filling in what we know. All right, we have 850, and notice there's a period at the end of that indicates the level where that this is going to have 3 significant figures. All right, specific heat 4.18 joules per gram per degree Celsius, and the temperature change of the water. And so taking the difference in temperature between the end temperature and the start temperature of the water gives us this delta T of 17.9 degrees Celsius. The mass of the metal is 252 grams. All right, we don't know what the identity is, but we can, even if we don't know its identity, we can figure out its mass by putting it on a balance. And its change in temperature is going to be 567.1 degrees Celsius. All right, so plugging all those numbers into your calculator. So putting all those numbers in your calculator gives this right here, and that calculated number is closest to the 0.444 specific heat of nickel. And so based on that calculated specific heat, so we're going to write, this would actually come out as 0.445, but you can obviously tell that that is closest to nickel on the reference guide. All right, and actually I should put units for that. That would be, let me just erase that. That would be joules over top of grams per degree Celsius. All right, so the next problem. Okay, we have here that the mCp delta T of the water equals the mCp delta T of the gold, because that's the the other substance that we're dealing with here. So do we know the mass of the water? We do have that. It's going to be 55.0 grams. We know the specific heat of water. We know the starting temperature of the water and the final temperature of the water right over here. So we can figure out the change of the temperature of the water. What is the original temperature of the gold? So we know, okay, we know the mass of the gold, that's 144 grams, and we know the specific heat of the gold. So the only part of this problem that we don't know is the delta T. All right, so if we can figure out how much the temperature changed by, all right, we should be able to figure out what the original temperature is, because we know that the final temperature of the gold is going to be 37 degrees, all right, or 37.0 degrees, because that's the final temperature of the water. And remember, the final temperature of the water is going to be the same as the final temperature of the substance that you're putting into the water. All right, so let's rearrange this, and we can say that the delta T of the gold is going to be m Cp delta T of the water over top of m Cp of the gold. So let's fill in what we know. The mass of the water is 55.0 grams. The specific heat of the water is 4.18 joules per gram per degree Celsius. And the change in temperature of the water is, we have 37 minus 25, that's going to be 12. Notice it's going to be 12.0 degrees Celsius because we've got that figure as being significant and that figure is significant. So that means we round that at that position right there. All right, that's going to be over top of the mass of the gold, which is 144 grams. And we are going to multiply that by the specific heat of gold, which we can look up on our data table, and that is 0.129 joules per gram per degree Celsius. All right, and notice one thing about these problems, I haven't been mentioning it, but anytime you see units twice, especially on this where you see the same units on the top and bottom, they cancel out. For example, the grams cancel out the grams here. The joules per gram per degree Celsius, all of these would cancel out with each other because they're the exact same thing, and it leaves the 1 unit left. All right, so plugging this number into your calculator gives this number right here, which if you look at the calculation, you can see that all of those have 3 significant figures, which means round that to 3 sig figs, which is going to be, so delta T, which is what we were solving for, is equal to 149 degrees Celsius. All right, but the thing is, that's not the final answer. That is how much the gold's temperature changed by. So to figure out what the original temperature is, well, we know what its final temperature was. That's 37.0 degrees Celsius. And if its temperature changed by this much, then its original temperature had to be that many degrees higher. All right, that's 149. All right, notice, so as far as sig figs, it's going to be rounded at this position right here. And if we do that, this works out to be 186 degrees Celsius. All right, so that's what that is right there. So again, with these calorimetry problems, they all start off with the same basic assumption, and it's just a matter of finding what is missing from the problem, and then just doing a little bit of math to figure out what that answer is. All right, thanks guys.